Thank you. I'm Jason Campbell with Panduit. We're going to talk about absence of voltage testers. So what is an AVT, or absence of voltage tester? Basically, it's a permanently mounted test system that indicates whether a panel is safe to enter. So it ties into the line or load side of the electrical system, typically in a control panel, MCC, other enclosure, and it will, when activated, it will tell you that the system's de-energized and the panel is safe to enter and service. What's the significance of an AVT? Basically, it does the live, dead, live test for you. It automates the traditional live, dead, live test. So OSHA says that lockout tagout is the second most willfully violated procedure on plant floors. So a lot of injuries and a lot of citations occur from skipping a lot of the de-energizing steps required to service a machine. Absence of voltage testers take out that human error step. They're permanently mounted in the enclosure. It reduces chance of human error or just willful neglect of taking the steps to properly de-energize and properly test for de-energization of the system. UL recognized the AVT as an approved test device for de-energizing of electrical panels. In 2016, it was recognized. The NFPA 70E added it to the 2018 revision. So in section 120.5, step 7, there's an exception to the live, dead, live test. So that section there talks about taking a portable tester and following the live, dead, live procedures. Now, if it's permanently mounted and installed in accordance with the manufacturer's recommendations, and if it's listed for the purpose of verifying absence of voltage, which is the UL certification, and if it tests each phase to phase and phase to ground, then it is allowed to be a valid substitution for the live, dead, live test that's normally done manually. So that was written in 2018. So here's a comparison. Basically, it automates a large portion of the live, dead, live test. So at the top is your traditional live, dead, live test. You gotta throw your breaker. You still do that, obviously. You gotta suit up in your PPE. You gotta go get your test device. Then you gotta go open up the panel, do your live, dead, live test, which is very manual. It can take 10 to 20 minutes, depending on the application that you're testing and the machinery that you're testing. The AVT basically automates a large portion of that in about 10 seconds. It provides the test results. So you don't have to suit up in PPE. You don't have to go find your portable tester. You just walk right up to the panel. The test is done external to the panel. You don't even open the door, right? After you've thrown your disconnect, you hit the button, and it'll give you an indication whether you can service the panel or not. So this is what it looks like at the door. It's a very simple red, yellow, green scenario. So when power is to the panel, you get a voltage indication, which is shown right there. So you show your 3 phases, and if a phase were to drop out, it would indicate that as well. So it does voltage indication. Once you disconnect power to the panel, the indicator module goes blank, right? At that point, you hit the test button, and it'll flash yellow while it's under test. And then if the panel is safe to enter, and safe to enter is qualified by UL as 3 volts or less. So if the panel is safe to enter, it gives you a green indication. Now, if it's not safe to enter, the yellow hazard light will flash a certain code. So if there's voltage above 3 volts, or if there's not enough power to complete the test, or if the self-diagnostics failed for some reason, the indicator module will tell you as well. At that point, you just go to your traditional manual test and do a traditional live, dead, live test. In order for UL to approve this and for NFPA 70E to adopt it, we had to make it a smart system. And basically, the AVT system has to do a full self-diagnostic test twice. So it checks, make sure that it has enough power to complete the job. It checks all the circuitry, make sure it's working correctly. It calibrates itself every time, checks its calibration. It then does the electrical test, and then it redoes all those tests one more time, still make sure that it's working correctly. And that all happens within 10 seconds. At that point, it'll give you that indication whether it's acceptable to open the panel door or not. So these are the major components of absence of voltage tester. You can get different accessories too for it, but basically you have 30 millimeter knockout indicator module at the door. You have a communication cable going back to the isolation module. Isolation module is den rail mounted or flush mounted on the back panel. You'll see all the leads coming out of that isolation module. They're 2 leads per phase and 2 leads to ground. So you have 8 wires to connect into the system. And that's because the equipment has to also check that it's connected properly. So a wire hasn't just come disconnected because of vibration or something. So it does a positive connection test, and 2 wires to each phase and 2 wires to ground ensure that that happens. By the way, the system also doesn't bring any voltage or any high voltage to the door. It's less than 5 volts going to the door, so you don't have any high voltages to worry about at the indicator module as well. This is basically the system, how it's designed. So again, indicator modules tested at the door itself. Again, it keeps hazardous voltages off of the door, which is a huge advantage over some other devices out there for testing at the panel door. And then you have the isolation module mounted at the back. You can also have dry contacts coming off of here, so you can do some other integration like additional lights, or at the booth we have one that has electronic interlock hooked up to it, so when I hit the button, the door pops open. All right, you can get into some pretty interesting integrations with a AVT. We launched the AVT in 2017. The original version, which is still on the market, tests AC or DC up to 600 volts. It's a SIL level 3 rated safety device. It has overcurrent protection of it's category 4 at 300 volts. And we're releasing in July AVT 2.0. So some of the enhancements to it is it goes up to 1,000 volts now, AC DC, 3-phase or single phase. You can wire it as well. It has network modules, so you can actually export all the data from it. So not only when the tests occurred, whether they passed or failed, but it also does some voltage monitoring. So you can measure phase to phase, phase to ground, RMS, and also peak voltages. And then you can collect all that data, and we have the add-on profiles for Rockwell controllers and all that integration. You can also now hook up 2 indicator modules per test point. So some people want 2 areas to test. So if you think of like equipment inside of a cage, maybe you want a test button outside the cage and then one at the panel door as well. As a good example of where you'd have 2 indicator modules. Another feature that we've built into the latest version is that the indicator modules, when you disconnect the panel from power, you still need some way of powering this device to do the test. So the indicator module has a little AA lithium-ion battery in there. It's accessible from the front, but some people don't like having servicing batteries on the plant floor. So we came up with a battery-free option. That indicator module is powered up through power over Ethernet or through control voltage, either way. So you've got 3 ways of powering this up, either through a single or AA battery, PoE, or a control voltage. So that version, which I have over at the booth, is coming out in July as well. And that is the AVT. So any questions about the technology?